Hello and welcome to our lesson on complex numbers. This is going to be from section 7.3 in our text. Let's get started. First of all, what are we going to cover in this lesson? Well, we're going to cover writing complex numbers in terms of I, adding and subtracting complex numbers, multiplying complex numbers, simplifying rational expressions. That means we're going to be dividing complex numbers, and simplifying higher powers of I. All of that covered in this lesson, and I think the best place to start would be with an example. Alright, so if you're wondering, why do I need complex numbers? Where did they come from? What's the reason they exist? This is a good basic example here. So when you're trying to take the square root of a number, you're looking for two identical factors that multiply and make that number. Unfortunately, there are no two identical factors that will multiply and make a negative number. So mathematicians, along the way, they reached this point where they had the square root of a negative number, and they needed to be able to simplify that in a way such that they could go on with their calculations. So this is where complex numbers came from. And the way it developed is they figured, well, any negative number can be written as that positive number times negative 1. And since we know that factors under a radical can be separated into their own radical symbol, they were able to break off this smallest negative factor, which is the square root of negative 1, and then they gave that a value. So that's where you need to know this first piece of information, and that is I is the square root of negative 1. Anytime you see a square root of negative 1, you can replace that with I, because I is designated to be the square root of negative 1. And so that allows us to take this example and go further. So we can square root 25, that's 5, and the square root of negative 1 is I. And then that would be considered to be simplified completely. Now, for those of you that love using the calculator, I've got some good news for you. On the Casio Class Whiz, if you type in the square root of negative 25 and hit equals, it's going to give us an error message, but that's okay. All that means is that we're in mode 1. So if we hit the menu button and go over one tile, you're going to see that menu option 2 is complex. And it even has a little I there to indicate that those are complex numbers. So we're going to select number 2. And now if we type in the square root of negative 25, it's going to give us the complex number. It's actually going to simplify that in terms of I. So that makes the Class Whiz super nice to have as a tool. Alright, so now that we know that the square root of negative 1 is I, focusing on this first objective, writing complex numbers in terms of I, we've already done one example. Let's try another example. So for number 9 here, they want us to simplify completely. It says to write the number in terms of I. And the first thing that I want to do is I want to rewrite this as 98 times negative 1. And then we know the square root of negative 1 is where I comes from. So if it's okay with you, let me introduce you to a little shortcut here. Anytime you have a square root, which means you have an index of 2, if you have a negative number under the radical, you can simply take the negative sign and bring it out, and that'll turn into an I. That is the fastest way I know of to simplify these complex radicals. The negative comes out and turns into an I. And then, if the number underneath is not a perfect square, you're going to need to try to break that down into factors where one of them is a perfect square. So let's think. Numbers that multiply to make 98, that would be 2 times 49. Just thinking of 98's an even number, so I know 2 goes into it. And look, all of a sudden I have my factors where 49 is a perfect square. So we're going to rewrite 98 as 49 times 2. Doesn't matter what order those go in. And then we know the square root of 49 is 7. So we can simplify that part. But the square root of 2 won't square root. So my answer is going to be 7i square root of 2, simplified completely. Or you can express that as 7 square root of 2i, making sure that the I is not under the radical. Either one of these answers would be considered correct. I think that I really like this one better because it shows the coefficient of I. It's a little bit harder to see the coefficient of I written this way. And I think we'll try one more example. Number 10, we have the square root of negative 28. And again, let me show you just how quickly this goes. Remember the negative under a square root? That turns into an I. We know that numbers that multiply to make 28, 4 times 7 is 28. And the square root of 4 is 2. So the 4 can come out as a 2. The I is out front because it was negative, and the square root of 7 is going to be left over. So that's 2i square root of 7 or 2 square root of 7i. Either one of those, again, is fine. And just for fun, I think I would like to try number 10 in the Casio and see if it does simplify it to simplest radical form. So that was the square root of negative 28. Oh, and look at that. And the Casio gives it the way I actually prefer. 2 square root of 7. Notice the I is not under the radical. So we can clearly see the coefficient of I here is 2 square root of 7. That is fantastic. All right, so that takes care of objective number 1. Next, objective number 2, we're going to look at add and subtract complex numbers. And that means we need to talk about standard form. So, when your complex number already has an I in it, standard form, a plus bi, the a is the real part of the complex number, and the bi, that is the imaginary part of the complex number. And so later you may need to know the value of a and b. Just remember that a is the real part and the bi is the imaginary part. That is standard form of a complex number. So our next example, number 15, here we have two complex numbers that are being added. Notice we have our a plus bi, a plus bi. These are both in standard form. And this is probably one of the easiest things you'll ever do in math is to add complex numbers, because all you have to do is add the real parts together and then add the complex or the imaginary parts together. So 12 plus a negative 8, that's going to be 4. And then 3i plus 5i is plus 8i. All right, so you know, basically what you're doing there is you're just combining like terms. The 12 and the negative 8, those are both the real parts. Those are like terms. The 3i and the 5i, they both have an I. They're like terms. They can be added. And I've got some more good news for you. The Casio ClassWiz can do this as well. Now that we're in complex mode, remember that is menu and option 2. We can simply type this problem in as 12 plus 3. Now to get the I, that's going to be the ENG button. Notice it has a little blue I above it, and that'll get your I on the screen. Plus negative 8 plus 5i. And notice that it gives the answer that we needed. So the Casio ClassWiz is also going to add and subtract complex numbers for you. You just need to remember that you've got to be in complex mode. Next example, number 23. Here we have subtraction with complex numbers. And this, again, this is just about as easy as addition. The only thing you need to remember is that this minus needs to distribute and that will change the signs. So we're going to have 13 plus 9i. That'll become minus 8 minus 2i. And then you just CLT. Combine like terms. 13 minus 8 is 5. Positive 9i minus 2i is positive 7i. And again, if you want to check that with the calculator, that is super easy. Just go to the class whiz and type the problem in. 13 plus 9i, the E and G button, remember, is I, minus 8 plus 2i, 5 plus 7i. Bam. And again, if you're keeping score, that is the second objective done. Add and subtract complex numbers. Next, let's look at multiplying complex numbers. And that's going to take us to number 35. So our next example here, notice that we have 7i. That is a complex number where the real part happens to be 0, I might note. So this would be considered a monomial. There's one term. Inside, we have a complex number, a plus bi, and it's a binomial because it has two terms. If I'm going to multiply these together, I need to use the distributive property. So multiplying 7i times 2, you just multiply the numbers together. 7 times 2 is 14, and the I comes along for the ride. Next, 7i times negative 5i. We're going to multiply the coefficients, and then we'll multiply the i's together. 7 times negative 5 gives me negative 35. I times I, just like x times x, is x squared. I times I is I squared. And then this is one of those key elements that you need to be able to recognize and deal with when you're doing complex numbers. And so this is where I get to point out this little fun fact from the notes. I squared is negative 1. And I have it highlighted in the notes because it is super important. It comes up often when you're doing complex numbers. What it says anytime that you have an I squared show up in your problem, you can replace it with negative 1. In other words, you can substitute negative 1 in place of I squared because that's what I squared is. And so coming back to our example, we can now see this is going to be 14i minus 35 times I squared, again, is negative 1. And then we're going to multiply these together. So a negative times a negative makes a positive 35. And the plus 14i goes at the back. And the reason that is because the answer needs to be in standard form. A plus bi. Our answer always needs to be in standard form. And that's going to do it for number 35. Next example, number 45. Here we have two complex numbers being multiplied. They both have an a and a bi. So since this is a binomial times a binomial, we're going to get to F it up. That's right, we're going to get to FOIL it. Here we go. First, 8 times negative 2 gives me negative 16. On the outside, negative 5 times 8 is a negative 40i. On the inside, negative times a negative gives me a positive 6i. And last but not least, a negative times a negative gives me a positive 15. Oh, and look at this. I times I gives me I squared. And remember, that is super important to notice. So the next step says we need to combine like terms. Negative 16 comes down. Negative 40 plus 6 is a negative 34i. And remember that I squared is the same as negative 1. So we're going to replace I squared with -1 and multiply these together. 15 times -1 is -15. Now that and the -16 are like terms. And so our final answer is -31 minus 34i. That is our final answer in standard form. And guess what we're going to do? Yeah, we're going to check it with the calculator. Let's see if the Casio will multiply complex numbers together. 8 minus 3i times -2 minus 5i. Whoo, look at that. Wow, the Casio does all of the FOIL method. It replaces the I squared with -1. It combines like terms. It does all of that work for you to give you the complex answer, and it's in standard form. That is fan-freaking-tastic. All right, so again, if you're keeping score, that's multiplication with complex numbers done. Now we need to look at simplifying rational expressions. Remember, rational means fractional. So we're going to be looking at fractions with complex numbers and how to simplify them. So our next example, number 65, here we have a fraction. Notice that it has an I in the denominator. And if you think back, remember what we said? I is the square root of -1. And that means that this is technically a fraction with a square root in the denominator. And if you remember anything about math, you know that it's bad math etiquette to leave a square root in the bottom. So all that to say, if you have an I in the denominator, you're going to have to rationalize. In other words, you're going to have to get the I out of the denominator. So here's how we do that. We're going to take the denominator and we're going to change the sign. That's called the complex conjugate. We're going to multiply the denominator by its complex conjugate, and whatever you do to the bottom, you have to do to the top. So we're going to multiply top and bottom by the complex conjugate. The numerator is going to be super easy. All we need to do is distribute the 3, and that's going to give us 15 plus 33i. In the denominator, since we're multiplying binomials, we're going to have to do the 4-letter F word. We're going to have to FOIL it. Here we go. 5 times 5, 25. On the outside, plus 55i. On the inside, minus 55i. And last but not least, -11 times 11, that's -121. I times I gives me I squared. And then we need to simplify the denominator. First thing I'm going to do is combine like terms. Notice the 55 i's cancel, the i's go away. And remember that I squared is -1. So we're going to do a substitution there, replacing I squared with -1. And since that is indicated multiplication, -1 times -121 is going to turn that into a plus 121. And then I have like terms, 25 plus 121. So we're going to have 15 plus 33i all over 25 plus 121 is 146. Now that is the correct answer, but it's not in standard form. And so we do need to express that in standard form. What that means, it means we need to separate this into a real part and an imaginary part. So separated, that would be 15 over 146 plus 33 over 146. And I'm going to stick the I out to the side because the 33 over 146, technically that's the coefficient of I. And then you need to make sure that these fractions are reduced to lowest terms. Now the way I'm going to do that is I'm going to use my Casio. So checking to see if 15 over 146 is reduced, and it is, and then 33 over 146 is in simplest form too. And so this is going to be my final answer in standard form, reduced to lowest terms. And just for fun, we're going to see if it'll recognize this needing to be rationalized. So with our fraction button, we're going to put in 3 over 5 minus 11i. And fingers crossed, bam! Look at that. The Casio automatically recognizes that as something that needs to be rationalized, and it gives us the answer in standard form. Again, that is fan-freaking-tastic. And just for fun, I thought we would do another rational expression with a complex number. This one's going to be a little more exciting. First of all, the numerator is a binomial. It's a complex number. But also, notice the coefficient of I is square root of 3. So this is actually going to be a lot of fun for me. Now, remember that if you have an I in the denominator, that corresponds to a square root in the denominator and therefore needs to be rationalized. And the way we're going to do that is we're going to multiply by the complex conjugate of the denominator. And that's going to be 5 plus for I. The complex conjugate is always the complex number with the opposite sign there. And whatever you do to the bottom, you have to do to the top. So we're going to multiply the numerator by 5 plus 4i as well. And that's going to indicate the FOIL method twice. We're going to have to FOIL the top and FOIL the bottom. Curses, FOILed again. Here we go. In the numerator, 2 times 5, that's a 10. On the outside, 4 times 2 is 8i. On the inside, now this is where things get interesting, 5 times square root of 3 is just 5 square root of 3i. And then last but not least, 4 times square root of 3 is 4 square root of 3, but we have I times I, which is going to give us an I squared. All over. In the denominator, 5 times 5 is 25. On the outside, plus 20i. On the inside, we have a minus 20i. And last but not least, negative 4 times 4, that is negative 16. I times I gives me I squared. Now, we need to simplify this mess. So, the first thing I notice is that I've got a couple of I squareds. Remember that those get replaced with negative 1. And what that really does, anytime you have a term with an I squared, you can just erase it and change it. Did you see that trick? The I squared, you erase it, and then you change the sign. That's basically what's going to happen there because you're multiplying by negative 1. And then, let's go ahead and do the denominator first because it's probably the easiest part to deal with. We're going to have 25 plus 16, which is 41. And notice the 20 i's cancel. So the denominator simplifies to just 41. In the numerator, we've got this 10 and the minus 4 square root of 3. Those are the real parts. And then we have the plus 8i and the plus 5 square root of 3i. Those are the imaginary parts. And so this is going to be a little bit tough to simplify to standard form, but we're going to make a go of it here, okay? We need to get this in a plus bi form. So since these first two terms are the real parts, we're going to say that is 10 minus 4 square root of 3 all over 41. And the 10 minus 4 square root of 3, that can't be simplified further. I guess we could factor a 2 out, but that's going to get that's not going to allow those terms to combine. So that would be considered the real part of the complex answer. Plus, now then, notice that these two terms both have an I. So what I'm going to do is I'm going to factor out the I, which is going to leave me 8 plus 5 square root of 3 all over 41. And if I stick the I out to the side, that means that I is multiplied by every term in the numerator. So in other words, what we have here now is this is my A, and this is my B, I. And so this should be the final answer in standard form. And I'm not going to expect the Casio to be able to give that answer. All right, so one more time, that should be our final answer in standard form. And just for fun, I'm going to put it into the Casio just to see what it gives us. So, 2 plus square root of 3. Don't forget you have to move out from under the square root before you put the I. Otherwise, it's going to put the I under the radical, and that would not be correct. In the denominator, 5 minus 4i. All right, let's see what we get. Oh my gosh, it gave us the answer. I didn't expect it to do that. That just shows how fan-freaking-tastic the Casio Class Whiz is. I never would have thought it would have given the answer like that, but it did. I wonder if it'll do this. If I hit the SD button, will it give me the A and the BI approximately? It sure did. So that's approximately 0.07 plus 0.41i. So the SD button is going to work for the complex numbers as well if you need that simplified to an A plus BI estimated. Okay, back to our scorecard. That takes care of simplifying rational expressions involving complex numbers. The last thing on our agenda is to simplify higher powers of I, and that's where this little chart comes in. So let me explain kind of what's going on in the chart here, and then we'll look at doing some examples. First of all, I to the 0, anything to the 0 is 1, so that's where we get that. I to the first power, anything to the first power is itself. I squared is -1, and then I cubed is -I, and the reason that that is because I cubed can be written as I to the 1 times I to the 2. Remember, if you multiply things that have the same base, you add their powers. So we can simplify I to the 3rd as, well, really I times I squared. And from here we can see that I is I, and I squared is -1. -1 times I is -I. So that's how we get I to the 3rd. Now, any higher power above I to the 3rd is just going to repeat in our chart. Let me show you what I'm talking about. So if I go to I to the 4th, that can be written as I squared times I squared. Do you see me breaking that down into pieces I already know? I know that I squared is -1. So then really I to the 4th should be -1 times -1, which is 1, which goes back to the first element in our chart. And then I to the 5th would be the next element, which is just I. And I know that because I to the 5th can be written as I times I to the 4th. I already know that I to the 4th is 1 because we just did it. 1 times anything is itself. So again, that's going to repeat. So now, how do we use this chart more effectively? You know, what's the shortcut here? Well, the shortcut is to divide. All right, so our next example, number 81, here we want to simplify I to the 35th power. And so the way we simplify higher powers of I is we're going to take the exponent and divide by 4. You always divide by 4. and 4 goes into 35 8 times. 4 times 8 is 32 with a remainder of 3. And then you're going to take that remainder to your table, and the remainder corresponds to the exponent. So I to the third is negative I. So I to the 35th is also negative I. Because the remainder corresponds to the exponent, I to the third is negative I. Therefore, I to the 35th is negative I. And I'm not sure if the Casio will do this, but let's check it, okay? So don't forget that you have to be in complex mode, mode 2. And then we're going to input I, that's the ENG button, to the, that's X to the little square, to the 35th. Look at that. It is going to give us the answer. So the Casio will also simplify higher powers of I for you. And one more example, just for fun, number 88. Here we have 2I to the 5th. Now, notice inside the parentheses, we have 2 factors. That is really 2 times I. And when you have multiple factors raised to an exponent, the exponent needs to distribute to both factors. So that's going to simplify to 2 to the 5th times I to the 5th. And then 2 to the 5th, we can do that manually or electronically. That's going to be 32. I to the 5th is a higher power of I. So we're going to take the exponent and divide by 4. 4 goes into 5 one time with a remainder of 1. Now that remainder, remember, corresponds to the exponent in our chart. And we know that I to the 1 is I. Anything to the 1 is itself. So I to the 5th is also going to simplify to just I. And I think I'm going to check that with the Casio. Please don't forget to use the parentheses. The 2I needs to be in parentheses, all raised to the 5th power, and it gives us the answer we need. And that's going to do it for this lesson. So if you have any questions or comments about anything I've covered so far, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.